A very important note here is every square matrix can be uniquely expressed as sum of symmetric and skew-symmetric matrices, which means a matrix A can be expressed as half of A plus A transpose and half of A minus A transpose. Now let's prove this, which is symmetric and which is skew-symmetric. Let's assume this part as P and this part as Q. Now let's prove whether P is a skew-symmetric or symmetric matrices by taking P transpose, which means half A plus A transpose ka whole transpose. We can write it as half A transpose plus A, which is the same P, right? A plus A transpose, which is same P. So now here we can tell P is a symmetric matrix. Now this part is a symmetric part. So now let's prove whether Q is symmetric or skew-symmetric. By taking Q transpose, we can write it as half of A minus A transpose. Now this half of A transpose minus A. Now take minus common, minus half of A minus A transpose, which is minus Q, which tells Q is a skew-symmetric matrix. So matrix can be expressed as sum of symmetric and skew-symmetric matrices. Now to prove the uniqueness of the theorem, take to prove uniqueness, take A as some random r press x. Now here R is a symmetric and S is skew-symmetric, which means R transpose is equal to R and S transpose is minus S. Let's assume this is first equation. Now take the transpose. You'll get A transpose will be R transpose plus S transpose, which means R minus S. This is the second equation. Solve 1 and 2. You will get it as A plus A transpose is 2R, which means R is half of A plus A transpose. Similarly, S becomes half of A minus A transpose. This is the uniqueness of this theorem. Express a matrix as sum of symmetric and skew-symmetric matrices. How to express this? To solve this kind of questions, let us assume P as half of A plus A transpose and here what does it mean? Half of A plus A transpose, like now we can solve it as half of A is 3 minus 4 1 minus 1 plus A transpose. Rows become column, column become row. 1 minus 1. Now just simply add. You will get it as 3 minus 3 by 2 minus 3 by 2 minus 1. Now we'll check whether P transpose is equal to P or not. Now P transpose becomes, from here, P transpose becomes row become column and column become row. So which is nothing but the same P matrix itself. Therefore, P is a symmetric matrix. Now let Q is half of A minus A transpose, which means half of 3 minus 4, 1 minus 1 minus 3 minus 4, 1 minus 1. Now when you solve this, you'll get it as 0, minus 5 by 2, 5 by 2 and 0. I already told you for skew symmetric matrix, the diagonal elements will be 0. Now let's check by taking Q transpose. Q transpose becomes 0, 5 by 2, minus 5 by 2 and 0. Take minus common, you'll get as 0, minus 5 by 2, 5 by 2 and 0, which is nothing but minus Q. From here we can say Q is a skew symmetric matrix. Therefore, we can write it as A matrix as P plus Q, which is nothing but half of A plus A transpose plus half of A minus A transpose. Express this matrix as sum of symmetric and skew symmetric matrices. Solve this question by taking an example as the above question. Okay, try to solve this.